Hello, hope you are comfortable while watching this. And in this video, we are going to mix a lot of technologies. We are going to use the viewer, combine it with Stable Diffusion Models and ComfyUI, both in desktop and cloud, to generate realistic images from our scenes, from our 3D designs. Okay, so yeah, enough talking. Let me start by sharing my screen. I believe you're able to see it now. And okay, we start by talking about stable diffusion models. Stable diffusion models can take input text using natural language and generate images from those. As an example, let me use this sample here from Hugging Face to call, let's generate a black puppy Labrador. And as a negative prompt, what I don't want to see in this image, let me say I don't want not safe for work content, and I also don't want ugly, an ugly puppy. Once I generate this image, let me also change my camera. Now I'm talking to the correct camera. And once I generate this image, you're going to see that it's going to generate these options of images from a black puppy Labrador. But since I don't have any input image to guide this new output generated content, it is going to hallucinate a lot, and the options are going to be quite different. Here is in a field, we have grass in the back of the image, in the scene. Here we have some trees, so completely different. Now we are going to leverage another tool, the tool I called first ComfyUI, to better guide this process and control how it's going to be our output image. This tool is quite popular. We have shared a sample. We have a sample using that, and it has more than a year actually. And it is very like Dynamo for those of you that are familiar with low code applications. It uses this approach where you have nodes controlling the models that we are going to use, controlling also the prompts that we are going to provide, the positive prompt, the negative prompt, and the node that is going to process all of that together and generate our image. It's very easy to use, and you have two options. One is to use it locally on your desktop machine, and the second option is to use that in the cloud using one app that I'm going to share in the next video, not in this one. So first of all, talking about ComfyUI, I encourage you to check this repo here. This is open sourced. So you can check this everything here, and it has instructions for you to install. What I also use a lot is this ComfyUI wiki, and in here we have tutorials on how to use ComfyUI, how to install. You can find the installation here. In my case, I'm using on a Windows machine, but you can be using on a Mac or Linux, depending on your configuration. And once you have that installed, you'll be able to see that in a folder. I downloaded the portable version for NVIDIA, for NVIDIA video cards. So I can just open this here, and inside ComfyUI, I can have all of my assets. This is the place where we should put our models and everything required. For now, we can just run this batch file here. And once I run that, it will take some time. Should be just a few seconds. Let me pause the video, the recording. Oh no, is that already? Okay. So now I can go to localhost port 8188. And here I can see one sample workflow. And if I run this workflow, here I can control everything. I can control the strength of a model, the steps. This is the key node that we use to generate the images. And from that, This is going to start this flow. The time it takes depends on your configuration and your machine that you're going to use. And by default, it's going to generate this beautiful scenery, nature glass bottle landscape, purple glass bottle, and this is the result. If I queue once again, let me remove this. You can see, let's say I don't want to see anything not safe for work as well. Queue once more. This is going to start loading and generate a scene completely different. We don't have any image as output called latent image, so there's no way to control that. So now let's try this, but now using one viewer image, one image generated from the viewer. So to do that, we have one cool sample that is connecting with ComfyUI, which is this one over here, APS Viewer AI Render. You can use this one cloud version, or what I recommend the most is forking this sample and running from your local machine. This way you can change that. Maybe you don't want to load your models from Autodesk Construction Cloud, so entirely up to you. I already have a cloned version of this here. So let me see APS AI Viewer Render. And once I run this sample, okay, now it's port 8080. I need to log in because this is connecting straight from Construction Cloud. Let me just pause here. I have logged in. Now I can allow, and then I can click here, show sidebar. Let me write one random model or random sample. REC basic sample. I enjoy this one a lot. And you can generate an image for any place from this design. My favorite one is the living room. So let's generate this image like this. There's just this boring line. Let me hide this. Yeah, because it makes no sense to have a line in our stairs. And if you click here, you select this option, download images. This is going to trigger the desktop environment, the desktop workflow. So not working through the cloud. And if I click here, this is going to download multiple input images. In this case, we have 3.1. We have the input image from viewer, which is just nothing beyond a screenshot. We also have the normal map, and we also have the depth map. Don't worry about these two at first. We are going to focus on this one right now, and right after that, what is it? Right after working with this first one, we are going to improve our result by aggregating also the normal map and the depth map in our workflow. So now let's go back to ComfyUI. And in this workflow, we are going to use as latent image instead of this empty latent image. Let me delete this one and double click to add one input file as an image. I'm going to choose the viewer input file, PNG. This is going to be our, now we need to encode our image. And now we need to also describe our scene. So let me call it living room realistic. In fact, let me grab what we have in here. Copy this one, paste this here. Glass windows, studio lighting, light wood floors. Let's remove this. Architectural rendering, interior designs, glass windows. Let me also add uh, two chairs. Okay, now we run it once more. Oh yeah, we need to connect also this. And we run it once more. And you can see that this result, this output is going to be somehow connected, taking this input image as an influence. This will be the base image to be modified using this model over here and those instructions. As you can see, okay, it is completed. It is beautiful. It has some glass windows, two chairs here, but it has nothing to do with this input image that we had. Let me delete this here. One thing we can try to do is work on this, the noise here option, to add more weight to this input image. And if we queue once more, remove the strength of our text and add more strength to the input image. The result is somehow better, but it's not there yet. And yeah, it is not there yet. You can see that there are some missing pieces over here. Has the two stairs, the two windows, but we can improve this even further. And how we can do that? That's why we are going to use the control nets. In this case, the control net is basically a sample, is basically a model, actually. And the purpose of this model is to guide our stable diffusion, our stable diffusion model into the output image, generating an output image that's going to be more influenced by our characteristics from our input. In this case, as you can see here in the ComfyUI wiki, we have many options for control nets. One of them is this line control net, depth, semantic. You can add segmentation control nets. In this case, since you can take it from the viewer without many effort, we already have the code for taking the normal map and the depth map. We are using these both options as control nets to generate our output image respecting all of these characteristics. Okay. I strongly recommend you to read through it and yeah, experiment with the strength of our of the models, tweaking the strength of the inputs, the prompts, the negative and positive prompts, changing this image. The key here is experimenting. You should experiment to with experimentation. You can get to a better result in terms of the output image. Okay, I'm speaking a lot, so now let's go to action and let's start using our control nets. I'm going to use the as I mentioned, multi control nets, just like this sample. So I'm going to use control nets for the depth map and the normal map. The samples, the control net models I'm grabbing from this link here. I grabbed these ones already. Depth control nets and the normal. Where's the normal? This one over here. What you need to do is add those two models, download and add those two models into this models control net folders. After that, you run it once more, this ComfyUI, and it will be automatically available. Okay, so let's apply this To apply this, let me just rearrange these nodes. Okay, here. First of all, let's load the ControlNet model. Let's load first the def model, is already here. And now we are going to add a node to apply the ControlNet. Apply the ControlNet requires the ControlNet model. We also need to specify the image and the positive and negative prompt. So instead of adding directly to this case sampler, which is the node that applies everything, put everything together to generate the output, we are going to pass the negative prompt and positive prompt first to our def control net. Then we can pass that to this negative and positive, to this case sampler, sorry. We also have the tutorials explaining the case sampler and all of these inputs, what are they used for. So feel free to read through it. This is very interesting. Let me go back here. And now we need to add as input our def map as an input for applying this control net. So let's double click and load an image. We already have the depth map here. Let me just see if it is the same one. Might be different. Yeah, there's a different angle. So let me add this image over here. And let me increase the strength once again. One, okay. Let's try like this. Okay, everything looks good. So running once again. This is going to apply the control net. It will take some time. And after that, here is our output image. As you can see, it is understanding the stairs, at least these stairs over here. We also have this television and the two chairs already available. It is a lot more compatible with what we had in our output image. Even those lines here with the field, with the terrain is being respected. And the output is yeah, way better compared to the previous one without the control net. Now we have another option to add the control net. We added only one for that map, but we got two maps from the viewer. We got the depth map and the normal map. So let's do the same, but now for the normal map. So we just need to apply control net. And once again, we are going to pass the positive and negative prompts over here first, negative prompt here, positive prompt, negative prompt. Uh, we also need to load our ControlNet model. And in this case, this will be the normal map. Yeah, let's use this one. And I need the input image. So let's call the load image here. And this requires the normal map. Now, if we run once more, It will take some time. If you change the steps, you can have a better results, but it also increase the time it takes to generate the output image. So you want to test a lot and be careful not to have a process that takes like minutes to generate one simple image. And then here we have a variation. You can see that now the stairs are way better. Also, there are some chairs over here that you can see from the previous image. So it is a lot better compared to the previous case. And you can keep improving this positive prompt, detailing what is in our scene, the materials applied to each one of our elements. And with that, we can experiment with the output image. The secret here, the key here is once again, experimentation. Okay, experimenting with the strength, the noise, the strength of each one of these control nets, and with that we can fine tune the result. So this is how you can test for free. You just need your time and downloading these models. And with this workflow, you can experiment in your local machine. The next video, I'm going to share how you can do the same thing in the cloud in a workflow that is very similar to what we have with design automation, where you upload this design, trigger this in a cloud environment, and obtain the results, the outputs of the images in our buckets. Okay.